Today's problem was submitted by a viewer. Let's read what's written here. So a little bit of background about themselves first. And okay, the first question they submitted says, the circle x squared plus y squared plus 2ax plus 2by equals c encloses the point 1, 1 precisely when, and we have some options for the algebraic conditions needed to be satisfied by A, B, and C. Okay. So I think the way I'm going to go about this is, this is, let me write down this equation first. X squared plus y squared plus 2ax plus 2by is equal to c. So this is the set of points x and y which satisfy this will give a circle in the plane. But the key to understanding this question is that if I replace the equality with an inequality, then the set of points x and y which satisfy this will be the filled in disk. It'll be the disk. It'll be some disk. Okay. So what we want is for the point 1, 1 to satisfy this inequality. That's what it means for the circle to enclose that point. It means that the point 1, 1 is in the disk defined by this inequality. And then I will have to rearrange this to arrive at one of the statements given in the problem. So let's just go ahead and do that. And this is immediately statement C, right? So statement C reads C greater than 2a plus b plus 1, which is the same as what's above. And this is option C. Yeah. So this wasn't quite my first instinct. I had a first instinct that usually I like to voice out loud. But I quickly realized that my first instinct was going to be a bit of a nightmare. So my first instinct was to take the equation for the circle and write it in the more familiar form, write it like this. You would have to do some completing of the square manipulations and that kind of thing. So this is how you might be more familiar with the equation of a circle, where the center is x naught, y naught, and the radius is r. And then just sort of deduce for which values of x naught, y naught, and r the point 1, 1 lies inside this circle. So of course what you would need then is you would need the set of centers, x naught, y naught, and radii, such that the distance of 1, 1 to the center is less than that radius. This seems like a bit of a nightmare. A lot of different things to keep track of, and some algebra that you would have to do up front in going from one form to the other. But when you realize that you have the set of points on the circle defined by this, and the set of points inside the circle are the ones that satisfy this. That makes this a lot easier to solve. So nice little problem, really quick if you see this appropriate, correct approach to doing it. Thanks for the submission, and thanks for watching.